Okay, welcome back. Hope you found those 3 labs setting up the vSphere Trust Authority informative. Now we change gears into another point of centralized management, host profiles. Host profiles, we'll take a look at the benefits of implementing them, explain how host profiles feature works, use a host profile to manage ESXi host configuration compliance, and use host profiles to standardize your ESX server configurations across multiple vCenter services and instances. So what is this? Basically, host profiles are the centralized way to manage ESX server configurations. If you think about an ESXi server, the VM kernel installation, for instance, or anything involving setting up and configuring any ESXi host, it's basically done in 2 phases. There's the imaging phase, where you simply either install from an image or you have it downloaded from something like auto deploy. That's that first phase, just putting the image on the ESX server. Now that image doesn't have a whole lot of attributes other than you're going to put the image down onto a hard drive, you'll have to choose the language, you'll have to put a password on that system. And that's really about the imaging aspect. And then post-install is the configuration aspect. So you either console into the ESXi host, log into the host over the host client, you'll set the IP address initially through the console and then set up everything else either through a host client or probably even more likely through the vSphere client. But still, if you need to do this across 50 hosts, this can take quite some time. You'd want to make sure you have consistency across your hosts. With host profiles, we get to define a host configuration and store that configuration in vCenter server so that you can now then apply the same exact configuration uniformly throughout a cluster. That's where it's probably most important that every host in a cluster is built uniformly. So we can guarantee it with a host profile. You can also use host profiles to make configuration changes too. If you have configuration change requirements, you can make that requirement, the change requirement in your host profile, and then apply that change across your environment, guaranteed to be consistent. But generally what you end up doing is you define that you have a master golden configuration image from one of your ESX servers, and then you remediate that to all the hosts to make sure all the hosts in the cluster are built uniformly. So basically the process is this. You build one of your ESX servers to its complete configured state, right? The master golden image, if you will. But it's not really the image in terms of software. It's a golden configuration image that would contain things like the storage settings, the network settings, how many virtual switches, would the host join a distributed switch, right? You're not actually creating a distributed switch and putting that into the host profile, but what you could have is the distributed switch in your vCenter server and then the profile where the host joins the distributed switch. You can also include users, joining Active Directory, firewall rule settings, service adjustments, whether you want to have SSH enabled, for instance. I mean, these are all things that can be saved in a host profile. And even better is you can save advanced host settings. All those advanced server settings can be applied into a host profile. You set all that up, you extract a host profile from one host, and then if you need to, you can edit that profile. Take a look at that process. Adjust whatever attributes that need to be more commonly applied across the host in a cluster. And then you basically scan the cluster. That's step number 3 here. Scan the cluster to see whether the hosts are compliant, or as a host joins a cluster, it can have a host profile applied to it. So it's basically a 2-step. You'll have to scan to see whether your hosts are compliant with the profile. And if they are, great. If they're not, then you apply the profile to the hosts. So what does this look like, right? When you build a host profile, here we've extracted a profile out of a host. It's called local profile. And that's just what we named it in this example. We pulled it off of one host, and now we essentially attach that host profile to one or more other hosts. And this is where we're going to do a comparison. We basically do a compliancy check to see if, in this case, host number 1 is compliant with the host profile called local-profile. And as we can see, it actually reports here after checking compliance that it's non-compliant, and it will down at the bottom of the screen show us where in the host profile is this host non-compliant. It will show us, in fact, what the host setting is in some particular attribute and what the host profile says it should be. So we can see here some attributes have been set for one parameter setting in the host, and the profile says it's something else. In order to make this host compliant with its profile, you basically need to remediate the host with this profile to make them compliant. Here we have another setting that was disabled on the host, but the host profile says it should be enabled. So That's is great. You find out all the hosts that are not compliant with your standard, right? Because you're basically setting a standard across a cluster that says every host needs to be configured in such a way. Here we'll be able to do a comparative report showing each of the different settings that are not compatible with the profile. So then what do? Well, we generally would like to remediate. Now there's actually some things we can perform. You can do a pre-check remediation. It will actually tell you what it would do to remediate it. Sometimes a remediation requires a host to be put into maintenance mode. Sometimes a host profile remediation requires a host to be rebooted. So it will tell us everything that it would change, and also whether or not it would need to be put in maintenance mode or if it would need to be rebooted for it to take effect. And then, of course, you can then do the remediation as well. Now, one thing that you might do is also edit host customizations. So in any case, applying a host profile is, like I said, you can do a pre-check remediation. In fact, it will perform the pre-check remediation even if you select remediate. And it even tells you here, right? It says the system will perform the following tasks. It will create a virtual network adapter on a distributed switch with this address and so on, right? So it'll tell you each little thing that when you apply a profile to a host, here's what it's going to do to that host. And if it required maintenance mode, it would have actually said that right at the top of that list of tasks. So yes, you can edit host profiles, right? We call these host customizations because if you were to create a standard where you have network settings, storage settings, sometimes they can't be uniform. Every host is going to have probably its own unique device paths. Every host is going to have its own IP address. Every host is going to have its own iSCSI qualified name, for instance. Well, what you can do is after having created the profile, you can edit the profile to ensure that there may be attributes that can't be uniformly applied. When you extract a host profile from one host, that is basically all the settings of that host. If not all those settings can be applied uniformly, you can edit the profile, adjust the settings in the host profile to fit your needs at the cluster level. You can also continue on with copying these settings from, say, one host profile to another host profile, so you can actually replicate host profile configurations. And then when it comes to things such as IP addresses and things that do need to be uniquely defined per host, another thing we can do is do what's called an export of a host customization. This is a lot like when you have VM templates and you're doing guest customizations, and you can create a guest customization spec where you define network and other attribute settings that need to be uniquely applied to all the different machines. Well, we can do the same here for the hosts. You can export host customizations. What this does is it creates a CSV file that you can then export into a spreadsheet. What it will do is it will look at all the different attributes that are in this host profile that need to be uniquely assigned. For instance, every single IP address that would need to be defined for VM kernel ports. So the host's management address, its vMotion address, things like that need to have unique addresses. It'll basically take the host that we extracted the host profile from. It will use this as exported into a CSV file with all the different column headings that represent all the different fields that need to have unique addresses. You can now take that spreadsheet and you can start adding more and more host details from each of the different hosts that you're going to add. So for every host, you'll gather their MAC address, their IP address, and so on, and fill them in this spreadsheet. So now that you have a spreadsheet filled with all the ESX servers and all of their unique addresses, you're basically filling an answer file, so that when you now apply the host profile, you can then have it use the source of this customizations host customization spreadsheet to populate with this unique information. If we don't do this, export host customizations, when you apply the profile, what will happen is the process of applying the profile will prompt the admin to put in these unique details. So you can deal with the unique details without having to create host customizations. You'll just be prompted for those details when you're applying the host profile. However, if you want to make this as completely hands-free and automated as possible, you can pre-populate this spreadsheet by first creating the spreadsheet and understanding what are all the different column headings that are needed based on the initial host profile that we extracted. And then you fill in all the information from all the different hosts in your environment. And now we can then use that source to then populate the details into host profiles or into the host when we're applying the host profiles. Where this is probably the most useful is when ESX servers actually boot in a stateless fashion. That's using auto deploy. ESX servers can actually boot without a local hard drive, without a local boot hard drive, and they'll boot in a stateless fashion. So every time a host boots, it needs to have a host profile applied to it, and all these details need to be applied because the host is effectively stateless. So every time the host boots, this host customization is applied. That's really useful if you wanted to be able to boot this host and just not have to worry about setting all these details every time the host reboots. If, on the other hand, your host has a stateful installation, meaning that the actual ESX software as it is installed statefully on a boot drive, well, then these host customizations are probably just applied just the first time you get the host installed, which then loses some of the effectiveness of why did we go ahead and create all these host customizations. So customizations are great, especially for when you have ESX servers that are booting in a stateless fashion. One other thing you can do with host profiles is you can export them completely out of the vCenter system or export them out of the vSphere client, save them on your desktop as a text file. It'll actually save it as an XML format with a VPF extension or VPF file extension. That is just to indicate to you that that's a vSphere profile. And where this is useful is you can then take this profile and then import that into another vCenter server. So not only are you standardizing a cluster configuration, you could even standardize a complete vCenter to vCenter standardization. So all your hosts across all your vCenter servers are going to be uniformly or could be uniformly configured. So we'll see all that. You'll do a lab demonstrating these different tasks. You're going to, first of all, pre-configure your ESXi host so that it is not quite uniform with another ESXi host. You've got two ESX servers that we've imported into the inventory, and you're going to change their NTP settings. So one's going to be correct and one's going to be incorrect. What we'll do is we'll use the host profile to tell us about that. So create a host profile off of the first host. The second host has the incorrect NTP address. We will also export the profile to go through the export process, import it. Not that we have to do that. It's mostly just to demonstrate to see the process of exporting and then importing. You will then duplicate and then edit the host profile and attach your second host to this profile. You'll check to see that it's non-compliant, right? Because we actually changed the NTP settings to an incorrect NTP settings in the first task. So we'll show the compliance check proving that the host is not compliant with the designated profile. We'll go ahead and make a manual remediation. You're going to fix it yourself because you can always use the host profile to tell you what you need to fix. But you also will have another adjustment. We're going to introduce configuration drift, make a change on the host, then run the host profile against that host again, or at least do a compliancy check. We'll find that, again, the host is no longer compliant with this host profile. This time we'll use the host profile to remediate the host. And so that's an interesting demonstration of all those different attributes. So we took a look in this lesson to describe the benefits of implementing host profiles, that centralized configuration management for ESX server setup, explain how host profile feature works, and use host profiles to manage your ESX configuration compliance. And we also saw how we can use host profiles to standardize ESX configurations across multiple vCenter server instances. So go ahead and perform the lab exercise, and we'll see you in the next lesson.